to do that more soon.
My friends bought like 3 2 liters each.
Of
2 liters of like and cherry.
yeah,
Yeah.
gross.
Always nasty. You regretted it the next day, but
Okay. No. Okay. Let's talk about adding and subtracting radicals today. That's all we're gonna do. I think it's one of the easier lessons. If the radicand and index, the radicands, I should say, the radicands of two radicals, it's a lot of radical words, are the same, we can add or subtract the numerical coefficients. A lot of math words in there. Not sure if that means anything to you right now. The radicands are the same. Give me two radicals, the radicands are the same. See? Can't do it. Okay. What is a radicand? The number inside the radical. Okay? So if we have two radicals where the number inside is the same. So let's make the, what do you want to make the radicand? 7. 7? Sure. Root 7 and root 7. Let's give them different coefficients. What do you want the coefficient for the first to be? 3, and we'll make plus, what do you want the coefficient here to be? 8. Okay, so if the radicands and index, so they're both square roots, can't add a square root with a cubic root, of two radicals are the same, we can add or subtract the numerical coefficients. So this, we can actually add these together. Think of it in terms of, back in the day, if we had 3x plus 8x, what would that equal? 3x plus 8x would be 11. Yeah, 11 x's, right? We add the numerical coefficients. We add the numerical coefficients the same. The x stayed together. It's like I have 3 apples, but 8 apples. How many apples do I have? 11 apples. So if I have 3 root 7s and I now also have 8 root 7s, how many root 7s will I have? 11. We add the coefficients and leave the radical the same. That is how we add radicals. It's as if your radicand is like a variable of x. And you're adding like terms. So only like radicands can you add together, just like terms when you're adding variables. So, does root 4 plus root 3 equal root 7? Let's check. Type that in your calculator. Root 4 plus root 3. So let's quit out of here. Root 4 plus root 7, what does that equal? Nope. Oh, root 4 plus root 3. Johnson. 3 points, you're right, 7, 3. I don't trust myself these days. Okay, so 3.732. And what is root 7 equal to? 2.645 ... So these are definitely not equal to each other, right? So you can't just add the radicands together. We keep the radicands the same. As long as the radicands are the same, we can add the coefficients together. It's pretty simple. So this very first one, are the radicands the same? Yeah, so let's combine the numerical coefficients. 3 minus 7 is -4, and we leave the radical the same. So -4 root 5s. Okay, this guy we need to simplify first, because are the radicands the same? Not yet. How can we simplify the first one? We can square root which one? The 4. So this will become square root of 4 is, what's the square root of 4? 2. So it's going to become a 2 root c minus Square root of 9. Should I make this larger for you guys? Here. How about like 300%? Huge. There you go. Now there shouldn't be an issue. Okay, square root of 9. What's the square root of 9? 3. So if we're taking the root 9 out and making it 3, what do we do with the 3 and the 4? Multiply them. So minus 12 root c. Now can we combine these? Yeah. 2 root c's minus 12 root c's. How many root c's do we have? Negative 10 root c. On a side note, can c be anything we want it to be, or are there any restrictions on c? Can we put a negative in? Can c be a negative? If it's a square root. No. So c has to be greater than or equal to 0. We'll start getting in the habit of writing restrictions. Yeah. Why is it 12? When we square root the 9, we get 3. And we have to multiply these, the coefficient. Multiply with the coefficient that's already there. All right, so like terms. Which ones are like terms here? Root 11s and the roots. Let's use a yellow. Oops. Root 5. So we're going to combine like terms. So first the root 11s. 6 root 11 minus 8 root 11. How many root 11s? Positive or negative? 6 minus 8. Negative 2 root 11. And then negative 2 root 5 minus 3 root 5. Negative 2 minus 3. Negative 5 root 5. We're done. So we can only add or subtract like radicals. Are these like radicals right now? Nope. Can we simplify them? Sure. Can you break down 8? What perfect square goes into 8? 4 times 2 plus what perfect square goes into 18? 9 times 2. Square root of 4 turns into a, what is the square root of 4? 2, and the square root of 9 is going to be a 3. So we have 2 root 2 plus 3 root 2. Okay, so I'm pulling the 2 and the 3 out. They become the coefficients. How many root 2's do we have? No. You thought he was serious? You never know with Jace. Keeps you guessing. I know you weren't serious. Okay, so can you try 5? I'd like you to simplify each one of these radicals, and then whatever is like terms, add them or subtract them together. How did you break up 20? 4 times 5, so it became 2 root 5. Okay, how did you break up 45? 9 times 5, and so square root of 9 became 3 root 5. And 125. 25 times 5. And square root of 25 is 5 root 5. All right, 2 minus 3 is negative 1. Negative 1 minus 5, negative 6 root 5s. Okay. Now, theoretically, could you check your work? Yes, you could type this into your calculator, get the decimal, type your answer in. They should be equal to the same thing in decimal form, right? So we're just simplifying. So you can check your work. Should you go through 6? Do you want to do 6 or do you want to do it together? You don't care? Together? Okay. So, how am I going to break up the 12? What times what? 4 and 3. Whoops. 1 second. Let me just pause this. Okay. 50. What perfect square goes into 50? 25. 25 times 2. 75. What perfect square goes into 75? 25 times 3. And what is the largest perfect square that goes into 32? 16 times 2. 4 will go in, but we want the largest. Okay, what is it going to become for the first guy? What's the coefficient going to become? Well, square root of the 4, what's the square root of 4? The square root of 4 is, what is square root of 4? It's 2. And so what do we do with, if there's already a coefficient there? Multiply them. 2 times 2 is going to make a 4 root 3. Plus, the second guy is easy, root 25. 5 root 2 minus square root of 25 again. 5 root 3. And this last guy, square root of 16. What's the square root of 16 equal? It's a 4. And so what are we going to do with the 4 and 6? Multiply them. So what's that? Minus 24 root 2. So now we want to combine our like terms. So like terms. Who are like terms? Root 3's. And then the root 2's. So this guy would equal, okay, root 3's. 4 minus 5. Negative 1 root 3, or you could just write negative root 3. You don't have to write the 1. You can, it doesn't matter. 5 minus 24. Negative 19 root 2. And there's our answer. Okay. 7. Really quickly, I'll go through 7. I don't want to spend a lot of time with it. So 20 breaks down to what? 4 times 5. There's the x still there. And 45 would break. What perfect square goes into 45? 9 times 5x. So when you simplify this, square root of 4 will become a 2 root 5x minus, what's going to be your coefficient here? Minus 9 root 5x, because the square root of 9 is 3, and 3 times 3 will give you 9. So collecting like terms, 9 minus 2, or 2 minus 9, sorry. Negative 7 root 5x. Can x be anything? No, it has to be greater than or equal to 0. Can't be a negative number. You can square root 0, you just can't square root a negative number because this is a square root. Okay, so we'll add in that restriction. Okay, we're going to talk about simplifying radicals a little bit more, although we really don't need to because we did it yesterday. I need to add something on the bottom of this page, though. I'm going to zoom out a bit. Hey, that's enough. Okay, let's talk about restrictions a little bit more, because the more we talk about it, the easier it'll become. Okay, restrictions occur when a radicand contains a variable and the index is even. To determine the restriction, we set the radicand. This should say greater than or equal to 0. That's a mistake. Sorry. Add the little equal to symbol under the that. Okay, so I'm going to give you a couple examples. So, what if I had, let's start with the very simple one, root 4x. Oh, why 4? Let's do 5. Oh, we already did that. Root, thank you, 7x. Okay, so here, what would be the restriction on this one? X has to be greater than or equal to 0. Okay, how about something like this? 2x minus 3. So if you have a situation like that, that's not a monomial. So it's not as simple. Well, it's still simple, but not as simple. So we know we can't square root a negative, right? Give me a number, any number that if I put it in here, it'll turn out as a negative. Negative 1. 2 times negative 1, right, is negative 2. Negative 2 minus 3? Negative 5. So negative 1 wouldn't work, right? Give me another number. 7. 2 times 7. 14 minus 3. 11. Is that positive? That's okay. So we know it has to be smaller than 7, right? So how do we figure it out? We figure it out, we take our radicand, and we know that the whole radicand always has to be a positive number, or 0. Agreed? As long as this is greater than or equal to 0, you can square root it. As long as what comes out of this expression is greater, positive, or 0, we're good. So how do we solve an inequality like this? How do we isolate x? Add 3, treat it like an equal sign, and then divide by 2. Divide by 2. And so x has to be greater than or equal to 1.5, or 3 over 2. As long as it's greater than 1.5, see if I did 1, 2 times 1 minus 3 would be negative 1, right? But 1.5, 2 times 1.5 is 3, 3 minus 3 is 0. As long as it's greater than or equal to 1.5, it will be a positive value. Okay, so do one more. I would like you to find the restriction on root 3x plus 1. What's the restriction on x? It's kind of like when we found solutions back in the day of factoring. You should be sorry. You should be very sorry. You know what I did this morning? I broke 5 bowls. 5! This morning. Glasses. Exactly. Okay, 3x plus 1 has to be positive, greater than or equal to 0. So what would you do first? Subtract 1, then divide by 3. So x has to be greater than or equal to negative a third would be your restriction. Okay, that's how we find restrictions. Most of the restrictions you're going to deal with right now will be monomials like this. Okay, where it's usually just x is greater than or equal to 0. But as this unit goes on, you'll see ones like this. So I just want to kind of introduce it now so that it's not like, when you see it. Okay, let's do a couple of the next page, but we kind of already done this, right? Oh, no, I changed my notes. Oh, good. These are old ones. We're good. I'm like looking at the wrong thing. No. Okay, let's go. So you have an option here. It says add or subtract, and then we're going to simplify. Are these radicands the same? Yeah. Okay, so let's subtract here. 5 minus 15. Negative 10 root x to the 5. Are there any, can we simplify this further? Yes. We can simplify x to the 5th. If we can simplify after adding, or even before, we do that. So how can I break up x to the 5th? X to the 4 times x. And square root of x to the 4, what does that become? X squared. Negative 10x squared root x. Restrictions on x cannot be negative. So greater than or equal to 0. It's a square root, and this was an odd power. So no matter what, it's going to still be a negative. Or if you look at this final answer, there's still root x there. Can't be negative. Okay, cubic roots. Are these like radicands right now? They like terms right now? No, so let's simplify them. Okay, the largest perfect cube that goes into 500. Uh-oh. Okay, our perfect cubes, the ones I asked you to memorize. 8, 27, 64, 125. 125 times So I'm going to break it into two separate brackets. Well, you don't have to. We can keep it all in the same bracket if you want. 125 times, there's a 4 and an x. Okay, 32. Which one of these perfect cubes go into 32? 8 times, no, 8 times 8 is 64. 8 times 6, no. 8 times 4. There you go. Now I'm leaving some space here because I also want to, can I break down x to the 5th? What's the largest number I can, like, if I'm dealing with a cubic root, multiple of 3, what's the largest multiple of 3? Power of 3. And how many left over? Oh, I had made a mistake with this one. Can you do me a favor? It's really easy. Can you add a little power of 2 right there, and a little power of 2 right there? Otherwise, we won't be able to add these. Okay. So I just added a power. Sorry. Okay, what's the cubic root of 125 equal to? 5. So what will we do with the 5 and the 5 that's already there? Multiply them. Negative 25 root 4x squared plus cubic root of 8x cubed. 2 and x root, or cubic root. I forgot my little cubic root. That's how you lose marks on a test. I'm showing you so that you don't do the same thing. Don't forget those little 3's. Okay, are these like radicands now? Yes. However, can you add negative 25 and 2x? Not really. Okay, so you can leave your answer like this, or you can write it as negative 25 plus 2x in brackets, cubic root 4x squared. Okay, you're adding them together, but you need to add them before you'd have to put it in brackets. So it can be written either way when they're different. So you might see that in your textbook. Are there any restrictions on x? No. Why is there no restriction? It's a cubic root. You can take a cubic root of a negative. Okay. I kind of want to skip 3. Maybe we'll come back 3 if we have time. Okay? Let's go to the examples, the word problems. I'd like you to draw a right isosceles triangle. A right isosceles triangle. A right isosceles triangle. Doesn't matter how it looks, what angle you put it at. That does not look like a right angle. Can I draw it? Can I draw what you did? It's really cute. It's really cute. Okay, you could draw it like this, but where would you put the 90? At the top. That's a good 90. Or you could do this.
I thought that was pretty close.
It's cute. Sorry, I shouldn't say that, but it was. I don't know. Okay, so your isosceles means what? There's a 90 degree and there's also... What does isosceles mean? Two same sides are equal. So these two are these two. Okay, now they say the base is 12, so it probably looks like the first one, right? Because you're looking, it says determine the lengths of the two equal sides. So this guy is 12 or this guy is 12. It's just turned, depending on how you drew it. Just find the lengths of the equal sides. How would you solve this? Magic? I do magic every day. No. No SOHCAHTOA. Although technically, no, you couldn't. Well, if you did special triangles, you could actually. You could use your knowledge of special triangles to solve this guy. Yeah, because this is a 45 and a 45. Remember those? 1, 1, root 2. But then you'd have to, it actually makes it a little bit more difficult than using another way. If we call these both x, what's the relationship between these three sides of a right triangle? A squared plus b squared equals c squared. So x squared plus x squared equals 12 squared. What is x squared plus x squared? How do we add like terms? Not x to the 4. Chase? No, because you want it as a radical in simplest form. So I could show you special triangles after, but you can't use sine law? No, but it still doesn't help you because, if you use the sine 45 special triangle, yeah, that could work. Yeah. I could show you, yeah. But this is easier because x squared plus x squared is 2x squareds. Mind blown, right? Equals 144. Then what? No. Sorry. Divide by 2. Isolate the square. I feel sorry for you guys. I'm not very nice when I'm around her. Okay. Now what? Now, Chase. What you just said. Square root both sides. Okay. Now, normally we'd say plus or minus. Can you have a minus in this situation? No. So, can we simplify root 72? 36 times 2? Good job. Which equals 6 root 2. Okay, yes, you could have used sine law and special triangles in the sine law to solve that, and it would work. But, all right, one more. Priya's backyard is in the shape of a square. The area of her entire backyard is 98. The total area is 98 meters squared. Yeah, lucky Priya. She has an area, a tree area. In the bottom corner contains a tree and has an area of, so this area right there is 8 meters squared. What is the exact perimeter of the rectangular flower bed? Nope. Okay. In order to find the perimeter, we need to know it's a rectangle. And so we need to know 2 lengths and 2 widths. Okay? Because we want the perimeter of one of these. So we need to know its dimensions. How can I start? Like if I know the area of the big square, is there a way to get this length here and this length here? We know the area. What's the formula for area of a square? For a square, you could actually do a more specific formula. Side squared. Area side squared. So if you know your area, can we get our side? Sure, by doing what? Square root of it. Root 98 is equal to that. Root 98 times root 98, would that equal 98? Yeah. Simplifying root 98. What perfect square goes into 98? 49 times 2, which is 7 root 2. So we now know that each one of these dimensions is 7 root 2. Okay. How about our green tree space? Can we figure out its dimensions? We just did it. Okay. Or, because you know the area of the green area is 8 right? And area side squared. What's the side length? Yes, 2 root 2. Good job. So square root both sides, so 4 times 2, or 2 root 2. Yay! Good job, Chase. I'm sassy today. I like it. Okay, so do we know the full dimensions of the rectangle yet? We know the widths, right? The width would be 2 root 2, because that's the same. But we need to know this guy right here. How could I get this dimension? Subtract them. 7 root 2 minus 2 root 2, which is 5 root 2. So now we know that our rectangular bed is 5 root 2, 2 root 2, 5 root 2, and 2 root 2. How do I get the perimeter? Add them all together. 2 plus 5 plus 2 plus 5. 14 root 2 meters. Done. Don't forget units. Okay, I didn't do that one, question number 3. Do you feel like I should do that one?
No.
You're good? You don't want to? Okay. All right, so textbook, same textbook pages as yesterday. Different questions. So numbers 8 to 10 are ABC. 11, 13, 14, 15 is optional. Okay? So, thought we'd have more time than we did. But we did.